Okay, in this video, I want to do problem number 1 and problem number 2. Okay, so what does it mean for this set of vectors to be linearly independent? I'll say there's different ways of saying this. This is one way. These vectors are linearly independent if the equation C1 V1 plus plus CK VK equals W has at most one solution for all W in Rn. Okay, another way, an equivalent way of saying this is that none of the vectors are in the linear span of the other vectors. Okay, for number 2, what does it mean for them to be a spanning set? These vectors are a spanning set if the equation C1 V1 plus plus Cn Vn has at least one solution for all W in Rn. Okay, and finally the third one, what does it mean for these set of vectors to be a basis? They are a basis if they are a spanning set and they are linearly independent. Okay, now I'm going to move on to problem number 2. So problem number 2 asks to determine, are they linearly independent? Are they spanning set? Are they a basis? Okay, so basically, we're going to put it into a matrix and row reduce. We're going to put it into a matrix and row reduce. Okay, if there is a row of zeros, that means it's not a spanning set. If there is a free variable, it means it is not linearly independent. Okay, so the first thing that I'm going to do is subtract row 1 from row 2 and row 3. So this is 1, 1, 3, 5. 1 minus 1 is 0. Minus 1 is minus 2. 1 minus 3 is minus 2. 1 minus 5 is minus 4. 1 minus 1 is 0. 0 minus 1 is minus 1. 1 minus 3 is minus 2. 1 minus 5 is minus 4. Okay, now I'm going to just divide. I'm going to just erase what I have here and divide row 2 by minus 2. So it's going to be 1, 1, 2. Okay, and I'm going to divide row 3 by minus 1, or multiply by minus 1. So it just gets rid of these negative signs. Okay, and so next I'm going to subtract row 2 from row 3. So this is 1, 1, 3, 5, 0, 1, 1, 2. 0 minus 0 is 0. 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 2 is 2. Okay, so this is in row echelon form. It's in row echelon form. So in row echelon form, there is a free variable, so they are linearly dependent. There's no row of zeros. So they are a spanning set. Since they aren't linearly independent, they're not a basis. Since they're not linearly independent, they're not a basis, okay? Because to be a basis, they need to be both a spanning set and be linearly independent.